Here's about this side.
So x of n is the maximum of x1, x2, all the way up to xn. Let's not forget xi, iid. I'll put fd that indicates a finite distribution with mean mu variance sigma 1. It could be normal, it could be exponential, it could be Gaussian, it could be anything. Good. So I want to find the density of xn. You may ask, well, why should we find the density of xn? Well, if someone says the SAT scores range from have a normal distribution, mean 1200, standard deviation of 100, and if someone came and said, if that is the scenario, what are the chances that the maximum SAT score for that cohort is greater than 1500? Yes, sure, we can find the answer using the xi's, but we can also use the max. Yes, how? In order to find the density, I'm going to start with the nth order statistic, which is simply the maximum of all the x's. If I say that the maximum of x1, x2, all the way up to xn is less than or equal to x, what does it say about the other variables?
They're all less than
That they all have to be less than x. So that is equivalent to saying
they're all identical and dependent.
x1 is less than or equal to x.
Yeah.
x2 is less than or equal to x. x3 less than or equal to x. Dot 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 xn less than or equal to x. Yes. So this statement is equivalent to this statement. Probability x1 less than or equal to x. x2 less than or equal to x. Dot 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 xn less than or equal to x. Yes. Now, that is a joint CDF, regardless of whether oh, my bad, I take that. That is a joint CDF. N-dimensional, yes.
Oh, those, can you pull, isn't the probability that any of them the same as any of the other are being less?
Why?
Oh, wait, because those aren't necessarily ordered, right?
They're not ordered.
Yeah, so then if they're independent, then you can just put a exponent.
Exactly. So the reason why we go for independent and identically distributed, because this becomes easy. If all of them are identical, I can simply call it sum x or xi for sum I. I don't want to call it xi. We'll just call the density to be fx of x. It's the PDF for any xi. And uppercase fx of x would be the CDF for any xi. And since we have IID random variables, I can use multiplication rule, probability of A and B. This is simply probability of A times probability of B under independence. So I can write this. Probability of xi less than or equal to x and multiply. That is nothing but permutation, correct? So for the ith random variable, I simply take the CDF and over there, I said no matter what random variable you take, they all have the same CDF. So I can drop the index and write it as this. And that would simply reduce to fx of x raised n. Okay. Now that we have the CDF of the nth order statistic, in other words, the maximum of x1 through xn, how do we find the PD?
Take the derivative.
Take the derivative. Oh, excuse me. If you take the derivative, let's see if you can give me the derivative. So we can simply use chain rule. This is u by function of x. So n u raised n minus 1 f of x raised n minus 1 multiplied by u prime. So derivative of fx of x. So what is the derivative of the CDF?
PDF.
PDF. So that would simply reduce to n fx of x raised n minus 1 fx of x. That is the density of the nth order statistic. Finding the CDF is pretty straightforward, it's right there. Yes. PDF can take a bit of work. So look at this problem and 8 students, their scores are distributed in a uniform manner, 75 to 92. And this is the probability that we want. Those are the probabilities that we want to find. Both of them are cumulative probabilities. That's one. Even before we start, at least 84. Do we expect a reasonably good probability or a very small probability?
Pretty good.
Pretty good, right? We're not saying what are the chances you pick a student and the probability is at least 84. We're actually asking what are the chances that the maximum score is at least 84. I will contrast it once we finish this. At most 72. Do we expect that probability to be large or small? Tiny. So if I say you have 8 students and their scores are uniformly distributed on this interval, and I'm asking, well, what are the chances it will just be 72 or below? Can't be high. So even before you start a problem, you can use intuition and try to come up with the correct answer. So first, we've got to start with a uniform. So test score, I'll call it U. They are IIT. So U uniform 75 to 92. What is the density of a uniform?
Divided by 2.
Divided by 2.
Or
N.
forgot.
It's the,
So
if you have n observations, it is, but if we're talking about an interval.
Oh,
92 minus 75.
thank you.
1/70. Yes. That will integrate to one for sure. What about a CDN? So find out from experience what the answer is going to be. In case you don't, what we can do is simply do integral. The minimum value of the support, which is at 75, to U. I'll use a dummy variable, fx of x dx.
Could you take an intuitive approach at this too? And just say, look at proportions.
Yes.
Yeah.
Um. 1/17 times dx. X is equal to 75, x is equal to U. And we end up getting U minus 75 divided by 17. U has to be an interval 75 to 92. Whether you put an open interval, closed interval doesn't matter because continuous doesn't. Yes. This is the same as saying U minus the minimum divided by the maximum minus minimum, the range.
Yeah, that's what I just kind of like brainstorming, but I didn't know if it would work.
But do we get it?
Huh?
Did we get it?
I ended up with 9/17.
9/17.
Well, maybe I went a little too far. And then
Oh,
I looked at just like what it means to be below 84. And that gives you a 9/17 chance. And then since they're all independent and identical, could we just say 7 of them are below and 1's above? And then just multiply those all up.
There are 8 students. And we want to know probability that the maximum score out of those 8 students is over 84.
Oh, that doesn't say anything. about
How's that 9/17?
Because the what did I do? I erased it already something. What do we have? 84 out of 92. So no, yeah, 84 minus 72. I mean 75 is the portion that would be below 84, right? So there's your 9.
So 75, 84, 92. 9. 8. Particulars actually. Somewhere over there, yes. 80. It's 1/17. At least 84. If I wanted to know what are the chances that the score would be at least 94, here it would be 8 divided by 17, right? And then you can intuitively go from there. Yes. Or we can use the density also of the maximum.
Oh, yeah, I forgot we could do that too.
N is 8. Yes. For U is simply F U raised 8. Correct. And that would simply be U minus 35 divided by 17 raised 8. Yes. The
Right, it's the worst.
the support of U here will be the same as the support over there. Do we agree? Support has to be the same. Great. Now, that is simply the probability that the maximum is less than. Agreed. How do we find that probability?
Wait. Here's almost, but don't we want at least one of them to be above, right?
No, we want the max to be.
Yeah.
Above, so we want 7 of them to be below. And then 1 of them to be above. Right, that kind of looks like we just want all, as soon as we put all 8 of them in the same bin.
So what would we get in our case? For the very first question, at least 84. Probability at least 84 would mean probability the maximum is greater than or equal to 84. Whether you put greater than or equal to or greater than, they are all in the same. I can write it as 1 minus the probability maximum less than 84. Less than or equal to, doesn't matter, we're dealing with continuous data here. But what we know is the second term is simply that. Agreed. So we will have 1 minus 84 minus 75 divided by 17 raised 8. One minus 9/17 raised 8. You need a calculator. I plugged it in the final answer here for that is 0.9938, even before we started. I said, or we came to a conclusion that it has to be a very high probability. Yes, the maximum score being greater than 84 must be a very high probability. Well, 99.38% chance that it is going to be bigger than 84 makes perfect sense. Yes. We agreed that the second probability at most 72 has to be very small. Because I'm telling you that the 8 students are distributed uniformly between 75 and 92. And I want to know what are the chances one of them is going to leave the school less than 72. Now, could it happen? Yes, but it is going to happen with a very small probability. What was it? 72.
Yeah.
And that directly would be the CDF of the maximum evaluated at 70.
How do we, yeah, the balance, so do something we're gonna do, is from 72 to where, or from where to 72?
Huh?
From like 0 to 72? Because we're gonna for the balance of the interval, right?
Yeah. I've not done it. So if you have 72. Have 72 minus 75 divided by 70. Raise 8. Now that's a negative number, correct? We cannot have a negative number.
Well, it won't be once we raise it to the 8.
Oh, I'm talking about the inside.
Oh, yeah, sure.
Yeah, 72 minus 75 divided by 17. That would be it. So 72 minus 75, negative 3, yes? When I raise it to the even power, I end up getting 9.4054 times 10 raised negative 7. Yes, great. You made a very good point. When you raise it to the power of 8, well, that's going to work for 8 students. What about 9 students? Are we going to stick with the negative number?
I guess you have to,
Right, probability cannot be negative,
right?
right?
So I get, if it's negative, you just take 0.
Here is the catch. Remember, earlier I mentioned
Yeah, support.
the support of the ordered statistic must be in the support of the actual random variable. Yes.
Yeah.
So in our case, the random variable has a support 75 to 92. So the correct answer,
It's undefined.
0.
Oh, 0.
It's not going to happen.
Okay, yeah, 'cause I thought the book said, like, it was like, they kind of gave a piecewise function, they made it like 0.
Oh,
One for,
yeah.
Good. So, who made a good point? Sure, I can do this. And in this problem, it's going to work out. It is going to be a very small probability. By all means, that probability is 0. Intuitively, it should be 0. But if you use this, you're not going to get 0, you're going to get a small number. And it works in this problem because the exponent is even. But we could have odd number of students in the class. So I can't have a negative number. So key thing to note here is the support of the ordered statistic has to be in the support of the original random variable. Does that make sense? It should, intuitively. Again, if I tell you students have scores from 75 to 92, the maximum score that the student will make, any one of those 8 students, will be here, right? I can't have over here. I can't have over there. It has to be within the support. Good. Now, erase. This is what Tim, I believe, was talking about earlier. I'll put the C, find probability for some time.
Out of the, how many?
8 people,
I'm still,
right? Out of 8 people, what are the chances? If I picked one student, that student's score is at least 84. What is the answer? Tim?
it's gonna be a long binomial,
Long binomial.
right? Doesn't like it's gonna have like, it's gonna have 2 terms or it's gonna have 8 terms? Or it minus 1 term, right? I can't remember. So, I read it on the bus. So that's-
Yeah, why do binomial?
Because we're gonna be, well, we have our independent, our identicals, we have some of those probabilities where we can. And you're either gonna be a success or a failure, basically.
Ah, I see, okay. We could do it. that way. But. Uniform, right? We want to find the probability, some random variable greater than or equal to 84. That's simply. All of those added together, correct? 8. 1 over 17. Area of the triangle. Eight over 17. Yes. If you pick one student. And if you ask, well, what is the probability? If you pick one arbitrary student and their score is greater than or equal to 84, that is 8 over 17. Another problem. I want you to see the differences between each case. Find the probability that all 8 students, doing this for 10, this is what he's thinking, have a score of at least 84.
Oh. Yeah, I'm trying to
Yes.
figure out. what it was.
With me so far. So this second part, 0, we got that. This is an important part, that's an important part, that's an important part. Oftentimes, students tend to confuse those. Here, I'm saying, well, I have 8 students telling you the scores are distributed uniformly on the interval 75 to 92. What is the probability if I pick one student, that student's score is at least 84, 8 out of 17. Close to 50%. Yes. Which makes sense, right? It's right okay.
It's just that.
Yeah. Yes.
So yeah, when are we gonna use the, where they should, or the PDF, oh, okay, we haven't got to the PDF.
We haven't got-
Okay. That's what I was thinking.
If I want to find the probability that all 8 students have a score of at least 84, that means the first one has a score of 84, the second has a score of 84, the third has a score of not 84, at least 84, and so on. So that case will equal to probability first one greater than or equal to 4, dot, 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 all the way up to the 8th one, greater than or equal to 84. Independent IID, yes. So I can simply say fx of 84, oops, 1 minus, raised to the power of 8. So it simply will be 8 over 17 raise 8. That is going to be sort of a small value. Does it make sense intuitively? Yes. If the scores are scattered uniformly between 75 and 92, and I'm asking, well, what are the chances every single one of them made at least 84? Can't be a very high probability. If it's a high probability, then it can't be uniform. So that value happens to be 0.0024. Small probability. 0.24%. Yes, very small probability. Now, this should make sense from a mathematical perspective. Out of the support, intuitively, doesn't make any sense because we're saying the scores are between 75 and 92. These two. If I say I is 8, yes, the 8th student would have a score of at least 84. Would that mean
Unordered, right?
exactly?
Oh.
So when I say the 8th student, I'm not talking about an order statistic. Imagine that I've labeled the students as 1, 2, 3, 4, 5, 6, 7, 8, the 8th student, but they are identical and independent, so they're not ordered. That is the probability. However, the maximum out of those 8 students would have a score of at least 84, will be an entirely different story. 99.38%. Yes. Why are we getting a high probability? We think about it, the maximum hypothetically, let's say you want to put a bell curve. It's going to be right here. Right? If hypothetically. And you're finding the probability over 84. Would be a very high probability. Yes. The distribution of the maximum has to be centered around the maximum to wait for it, but not on both sides.
I don't know if I see it 100%, because I still see the binomial distribution here. That
Here or there.
I feel like like, so, because we have all 8 falling into this bit, which is then so then if we do one complement, isn't that putting all 8 over here? And I thought we only need one over here.
We're not saying all 8 need to be here.
But isn't that kind of what this is suggesting over here, right?
No, that's not what it's suggesting.
Okay.
And I think you are confusing this statement, exactly this statement, with that part right there. If I change at least 84, yes, to at most 84, and if I asked you, what is the probability all 8 students would have a score of at most 84?
Oh, yeah, I see what you're saying.
Then you would say, first one would have a score of at most 84, probability 9 out of 17, and the second, and the third, and the fourth. So 9 over 17 multiplied itself 8 times, you would have 9 over 17 raised 8. That is the logic over here. The first student is over 84, second student over 84, all 8 of them over 84, that probability is 0.0024. But that is not what we are answering in this part. In this part, we're saying in this arbitrary class, what are the chances that the maximum score out of those 8 people would be at least 84? It has to be 99%, 99.38%. Good. Do you see the difference? The point I'm trying to make is saying that or asking or looking for the maximum score out of the 8 people to be at most 84 is not the same as asking or looking for the probability that the 8th person would have a probability of the case 84. Completely different things. And that is answering an entirely different question. You have 8 students, and I'm telling you, well, they are uniformly distributed between 75 and 92. What are the chances that every single one of them will have a score over 84, equal to 84? And that is simply multiplication.
Okay, in the PDF, I see it now, because yeah, the binomial PDF, that second term is n minus r, and r is n here, so.
Now you are looking at the unordered statistic, yes? You're looking.
For, yeah, the expected value of, oh, that's a little different. That's-
Yeah, we will get to that later. I'm simply doing the maximum in, and I'm going to generalize it for an ordered statistic. And that formula produce, I shouldn't say produce, you can use that formula to deduce the formula for the minimum, for the maximum. So last case, the density of the ordered statistic, that part is easy. We know it is simply n, so 8, going back to the formula, times u f x, yes. So in this case, u minus 75 divided by 17 raised n minus 1. So it's 8 minus 1 multiplied by the derivative inside, that's 1 over 17. So we will have 8 over 17 times u minus 75 divided by 17 raised 7. Got to keep in mind the support u is still in 75 to 92.